Good morning, bears. Excuse me, getting the frog ribbit out of my throat. We're starting off the day with a winner, 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 winner. As I'm browsing the slideshows today, and I stumble across a beautiful slideshow by Leilani. I'm like, wow, this is how we get it done. This makes me happy. So remember, Leilani is A-level work. She does the Mandy's. She looks at groups daily. She gets things done, and she does even more than that. So don't think you have to have all of this to get a C or a B. A C level, look at the concepts, do some research, do a little analysis, put some pictures. Just about any work and Zoom activity daily, you can be qualified for a C. B level, you're attempting some of this, and then of course A level, get ready to look at it. Hello and welcome to Leilani's Slideshow. Hope you enjoy. We know who the slideshow is. We have an introduction. We're learning about something we're not even there yet, which is warmer objects transfer to cooler objects. She's a little ahead of the game on that fantastic inference, which we'll get to in a minute. Notice we had a Mandy, how these systems are different, how they're similar, analyzing them and making a prediction. Another word for prediction is guess. Another word for guess is hypothesis. And she says, personally, I feel like the second proposal is better because the soil has a lot of water, which means more heat. So she's going with number two, proposal number two. We don't know right or wrong yet. This is just a guess. We're going to find out more about that later. Then she has her average slide, which we said, let's do an average slide. Some of you might have some numbers, which would be nice to do that. Remember, I'll do a quick one for you right here, just as a quick review. When you want to do an average, you simply add up the numbers. Say you had a 2 plus a 3. Let's just put the numbers 2, a 3, a 6, a 5, and a 4. And you say, what's the average? Well, first of all, you can kind of get it in your head by saying, what's the highest? That's a 6. What's the lowest? That's a 2. What's in between 6 and a 2? Well, 6 minus 2 is 4. And I'm doing some other statistical math I'm doing right now, but 6 minus 2 is 4. And so there's 4 in between 6 and 2. 4 is not necessarily your answer, but there's 4 spaces. So if you go 2 up from 2, 2 down from 6, you are at 4. So in this case, 4 is also possibly your average, but maybe not because there's all these other numbers. So let's go ahead and add them up. 5 plus 4 is 9. So let's start from the beginning. 3 plus 2 is 5. 5 plus 6 is 11. 11 plus 5 is 16. 16 plus 4 is 20. 20 divided by 1, 2, 3, 4, 5. 20 divided by 5 is, what do you know, 4. So my guess was close. By estimating, it's not always right, but it's pretty close. So you can do a lot of these things in your head. Anyway, great average slide. Infer. This is one of my favorite slides I've ever seen in my life. I'm not kidding. I mean, look at all those cool little pictures. She may have found this, but look how organized it is. I don't know if she made it. I don't know if she found it like this, but I know that it's really, really good to reach a conclusion using evidence or reasoning. So he implies, he throws the ball, he infers, I better catch it. Same with this one. Reading a book, you can learn and you can infer from things. Somebody doesn't always have to tell you the exact details for you to kind of figure something out, but it's with evidence and reason. So that's a great slide. Kinetic energy, another really cool one. Kinetic energy is movement. We're talking about molecules, but there's all kinds of stuff that we will study later because there's shooting a rubber band, elastic energy. There's gravitational, letting go, potential energy, and there's the potential energy here. She's showing that in this one. It's potential because he's holding it, but gravity can make that drop. It's not dropping yet. Let it go. Kinetic, the energy that an object has because it's moving. This ball moving down, depending on its size, weight, and speed. There's all kinds of physical equations for this stuff. You can predict how much damage it would do to a wall or something like that. How come this roller coaster doesn't fall out of the air? Kinetic energy keeps it pressed against the rails thanks to forces. And there's a lot of fun science with all of that. Thank you for helping us learn today, Leilani. She has her water freezing. Look at how organized this is. She has, why do molecules warm up? The molecules begins to move more and more faster as more heat is added to the molecules. Yes, as you heat molecules up, they move faster. How do we measure things? The faster the molecules are moving, the hotter it is. Play with the sim, you can learn all that. Temperature, oh my goodness. What a great slideshow. Everything you want to learn about right here. Look at this molecule. Leilani, so cool. What's a molecule? A group of atoms joined together in a particular way. Wow, I'm very excited. Thank you. Good job, Leilani. All right, let's get started with today's lesson. Now, it's a Thursday, Friday, epic. It's right here in groups, as always. Mr. Downs, I got kicked out of Zoom. Mr. Downs, I can't hear you. Mr. Downs, my Zoom is lagging. Well, go to groups. Student-led teaching on Friday, so those like Leilani could teach tomorrow using this essay we're about to write. First, we're going to read an article, and the link is below. Follow lesson video for read aloud. If not in Zoom, click and read aloud button at top. Question: are air conditioners good technology for cooling air and helping the environment? Kind of a two-question thing there. Create top slide. You're going to add this above question, and you're going to make a claim answering that question, this one, and write a CER FIST essay citing at least one evidence from the text. Which text? The article, which I will link below. Use your reasoning to explain your evidence and conclude with a claim. So you want to have a strong opinion here. Air conditions are worth it. They're good. They cool houses down, and it's not that bad for the environment. Or air conditions, while they might cool things down, they're not good for the environment. I need you to make that claim and support it with evidence. And we'll get into that article now. Okay, so before we go to the article, it's always helpful to have your slide and your question ready to go. Remember, we're writing a 5-sentence CER. You know how to write a FIST essay. This is Thursday, Friday, epic. So you have all day tomorrow to work on it in class. If you want to get it done today, you can, and then we can share yours at the start of class tomorrow. So first, let's go create our slide. So what you want to do right now is you want to open your top slide. I'm just going to go ahead and use Leilani's, and I clicked the wrong button. It's this little arrow, which you guys can't see. Create a slide that you like. I tend to like this one. And we're just going to put here, are air conditioners a good thing? So you can come up with your own title. Obviously, you want to spell it right. Or you can come to groups, copy this. Are air conditioners good technology for helping the environment? Just copy that, paste it into your slide. But you can come up with your own title because it's your own little article. And then you're going to write your claim essay here with evidence. Now you can add slides as needed. So let's make that slide now. If you do this, you're more likely to succeed in reading the essay because you're going to have this in your brain. So everybody make that slide now. Okay, so everybody should have a slide that looks something like this, ready to go. If you're advanced and you know how to make screens smaller and you can read along and take notes, that's fine. Now keep in mind, when you log into this article, the link is in groups, you can take notes in here, you can make comments in here, you can, once you comment, see that you have copy, you have notes, you can highlight. So if you're really advanced, you could play with opening this right now and reading along with the audio while I play the tape. Now, you can also do this on your own at any time by clicking this button. But for simplicity purposes, another way to do it is you just follow along with the video. I'm going to play this. We're going to look for clues. If we want evidence, are these things worth it? These air conditioners worth it? Or are they not worth it? We're also going to learn about molecules and things like that, and this information will help us next time we come back to figure out our cooling system for the school. You might want to come back and say, hey school, forget about that water system. Let's just get new air conditioners. They're way better. Or you might learn from this and say, nope, we don't want air conditioners. We're going to stick with the water system. So keep in mind, this little essay could be like a letter to that principal. Could also be a letter to the parent explaining them why air conditioners are no good and the water system will work better. Now we're not worrying that much about the water system yet, but this is analyzing another option that they didn't give us. Are air conditioners good? So think about that as we read. Here we go.
How air conditioners make cities hotter. On a hot day, walking into an air conditioned building feels great. You can leave all that hot air outside. Air conditioning makes the air inside a building much cooler, keeping you from turning into a sweaty mess during hot weather. How do air conditioners work their magic? Air is made of molecules, and the temperature of air is all about the speed of its molecules. Differences in air temperature are caused by differences in the energy of the molecules that make up the air, and the amount of energy those molecules have has to do with how fast they're moving. Air conditioners cool air by slowing molecules down. Unfortunately, the magic of air conditioning has a dark side.
Once again, I don't like it when they skip this. This air conditioning system sits on the roof of a building. It transfers energy out of the building's air to keep the building from getting too hot. So it transfers energy out. Interesting. So we're talking a lot about technology here. Remember, follow along. Makes you a better reader.
Air conditioners cool the air inside, but they make the air outside even hotter. Air conditioners can actually make heat waves worse. An air conditioner uses machines and chemicals to remove kinetic energy from the molecules that make up the air inside a room. This slows the molecules down and lowers the room's air temperature. However, energy can't be created or destroyed. It can only be transferred from one place to another. The energy that was in those molecules doesn't just disappear, it gets transferred to molecules in the air outside. This causes the air outside to warm up through a series of collisions between faster and slower molecules. As faster molecules bump into slower ones, kinetic energy transfers to the slower moving molecules, causing them to speed up. When the molecules of the air speed up, the temperature rises. When you run an air conditioner, you're making it hotter outside by transferring energy from the air inside a building to the air outside the building. The air inside and the air outside are two parts of one system, connected by the air conditioner. Changes in one part of the system affect the other part. In fact, one study showed that on hot nights when many people in the same town run their air conditioning, the temperature outside is about 1 degree Celsius, 1.8 degrees Fahrenheit hotter in that town than it would be otherwise. This rise in temperature means people use their air conditioning even more, and it can make things even worse in cities where the climate is already hot. This kind of energy transfer doesn't just apply to hot buildings, it also applies to hot foreheads. Have you ever been sick with a fever and wished you could do something to feel better? When you have a fever, one way to feel some relief is to soak a washcloth in cool water and lay it across your forehead. Some of the energy from your warm skin transfers to the cool cloth. When two things of different temperature come into contact, the warmer one will always transfer energy to the cooler one. In this case, your warm forehead transfers energy to the cool washcloth. How does that transfer actually happen? Since we know what happens to molecules when matter changes temperature, we can infer that the molecules collide with one another as they move. At the moment of collision, energy transfers from the molecule with more kinetic energy to the molecule with less. The fast-moving molecules of your hot forehead bump into the slow-moving molecules of the washcloth, transferring kinetic energy from your forehead to the washcloth. Your skin cools as the molecules of your forehead slow down, while the washcloth gets warmer as its molecules speed up. You can think of your forehead and the washcloth as two parts of the same system. Energy is transferred from one part of the system, your forehead, to another, the damp washcloth. As the temperature of your forehead drops, you feel better. However, that same washcloth won't keep you cool forever. Eventually, so much energy will transfer from your forehead to the washcloth that the washcloth and your forehead will be the same temperature, and energy will stop transferring away from your forehead. When that happens, it's time to get a new cool washcloth so that this energy transfer can keep going and you can keep getting relief. Whether you are cooling a room or your forehead, you need to transfer energy to do it. When one thing cools down, something else has to warm up. Since energy can't be created or destroyed, a change in temperature always means energy has been transferred. It always comes from somewhere and goes somewhere else.
Okay, man, that's a great little article. Covers a lot. Air conditioners, getting sick. So, if you think air conditioners are good, you're going to want to come into this article and find evidence that, hey, this thing cools the air down. If you're thinking negative, then you want to come down in here and find something like, look at this. Unfortunately, the magic of air conditioning has a dark side. That sounds negative to me. Air conditioners cool the air inside, but they make the air outside even hotter. There's some evidence there. Now notice I highlighted as I read through this. So right now what we're going to do is you're going to go into breakout rooms. Hopefully everybody in the breakout room can access this article. We've read it once. I want you to browse it. You do not have to read it out loud. You can just kind of scroll down and everybody in the room just be looking at the article. If one person can't open it, maybe somebody can share their screen. And just for about 5 minutes, I want you scrolling down and looking for information. Before you do this, talk in the breakout room. Do you think air conditioners are a good thing or a bad thing? Should we find a new way to cool the air inside our houses? Or do you think it's fine? So have that discussion. Then come up with, the whole room doesn't have to agree, but as you go through, you might say, hey, this is a good one for you because you like air conditioners. Oh, hey, this is a good one for us because we think air conditioners are negative. So you're finding evidence. I think you know what you'll do after the breakout room, but just keep in mind what you're looking for is evidence to put in your CER. You're going to want to get 3 citations. This is as long as you'd want a citation, this long of a sentence. Now, once you get that citation, we're going to narrow it down, but we'll do that next. All right, let's jump into the breakout room. Remember, this is Thursday, Friday Epic. We're basically doing our research today. You have all day tomorrow to write it, but some of you who like to write later in the afternoon or today, and if we have time in class today, you can start writing it. But right now, we're just looking for evidence. Air conditioners, are they a good thing or are they a bad thing? Let's dive into the breakout rooms. And Zoom will share out some of your findings, some of the top evidence. Remember, this link is accessible. The good thing about these links, if you access it through the link and get logged in, when you go back later, your comments, your questions, your highlights will still be there. And one thing that I want to show you as you use this later for some of you advanced kids, if you come in here and you go note, guess what? You can basically write your essay in here. So the magic version has a dark side. This is a clue that the article supports my claim that using aircon, you can use short if you want, is not worth the cost. It is damaging to the environment because it heats things up. So what did I just do there? In a CER, I have a claim. They're not worth it. I have evidence. This is my evidence. I'm going to copy this, paste in my article. And then I have a reasoning to put into my article. So now watch, I save this. Now, when I'm ready to write my little essay, if I'm only doing a 5-sentencer, guess what? I write an introduction. I copy and paste this with quotes. I copy and paste this, not quotes, because these are my words. I maybe give another opinion, and then I write a conclusion, and I've written a nice 5-sentence essay. Now, try to include a picture or two, and if you want to go to 3 to 5 sentence CR, that's fine. So that's what we're doing. This is our Thursday, Friday epic. Great job, Leilani. Let's get started. Remember, these essays, you have half of class tomorrow to work on it. There's no video lesson tomorrow. This article is here for your link. Browse it, learn from it. And if you have extra time, you can always go superstar mode like Leilani did and make all these fun, cool slides. Leilani, thanks again. Let's start writing. Have a great day, everybody.